Welcome back to our data science for life sciences class. We're going to dive right into the notions of statistics and talk about the mean, median, and weighted mean. I suspect that most of the students in this class have taken a statistics class before, or at least encountered these calculations before. So we're going to talk about things in more of a review sense. Hopefully that works out fine. I One thing that you'll see me do is kind of improvise. I actually first started teaching this class, Bio 18, at UC Merced 5 years ago. And I was previously teaching a version of this class at a community college. So I was doing things that made sense at the community college and not necessarily at the UC. And it's always been my plan to overhaul the class, to completely redo all my lecture notes and whatnot. And me being a masochist, I decided, hey, what the heck? While we're worried about Zoom and COVID 19 and everything else, let me just completely remake this class while I'm at it. So, with that in mind, I decided on a completely new setting, at least new to me, and we're going to pretend that we surveyed people and asked them how many push ups they did yesterday. It's arbitrary in that I could have asked like push ups per hour or some other rate. But let's just ask them how many push ups they did yesterday. And yes, I might have forgotten to mention, just to make things a little bit more lively, if you're watching this on the Twitch stream, if you scroll down a bit, there's a feature called stickers, which some of you found already. Every once in a while, feel free to just slap a silly sticker on top of the lecture. So one thing that we're gonna need to quickly discuss in terms of defining terms for our statistics class is the notion of populations versus samples. And for now, my quick and slick definition is just simply relating to two words that we survey a small sample of people to understand a much larger population. So, say for example, if we surveyed people on how many push-ups they did yesterday, and we got these numbers here. Again, completely hypothetical situation. And long story short, do not worry about the square brackets. If for some reason it was too difficult for us to deal with all this data at the moment, we would want to focus on a relatively small sample. So say if we randomly sampled some of these numbers here, oops, I should have used background color. let's say that those five numbers are a sample of a much larger population of data. Let me just get some of the definitions out of the way. If we're taking all the numbers and finding their average, this is denoted by the Greek letter mu, and the technical term is population mean. And if we're instead dealing with a relatively small sample of data, and we're doing a calculation with that relatively small sample, calculating the average, then that's denoted by x bar. I'm going to see how much I could type in just into the Google Docs without having to use a separate program. Could I type an equation here? Let's see. So our sample, first of all, are those five numbers: 22, 18, 17, 23, and 24 push-ups. And as you recall, in order to find the average, we add up all the numbers and divide by however many numbers are. Ooh, that's getting messy. Oh, I cannot make that more colorful. Dang it. And we get 20.8 push-ups. As always, if you do have a question, feel free to ask in the Twitch chat. The way I did that calculation on the calculator or in RStudio was that I combined the sample data using this lowercase c here, and I actually did this down here at the bottom of the screen. Now, saving that list of numbers as a variable, and you could name this whatever you want for the most part. I call this the example data. Then from there, in R, to find the mean of that example data, you simply wrap your data with parentheses and use the mean function. Now recall that I'm going to ask you probably at least once per lecture session a question, and I'll ask you to answer it. I'll ask about 10 people at a time, so that way I'm not calling on any one person, not necessarily picking on any one person, and also maybe welcoming a variety of answers as well. Furthermore, if I ask only a few people at a time, then it does not overload the Google Doc. So you might recall that there's another way to measure the center of a list of numbers, and that's called a median. And for the people that I've indicated there, could you make an educated guess or tell us how to compute a median? All right, so thank you for supplying us with the definition. As these folks have correctly mentioned, we, in some sense, want to find the middle number in the list of numbers. But in order for that to make more sense practically, we need to sort the numbers first. Now, fortunately, at least for this very awkward setting of the Google Doc, there's no set notations. Mathematicians never decided on a particular way to write out a symbol for median, so we could just use the word median. As the folks mentioned above, we put the numbers in order and look for the number that's located in the middle. Here, that middle number is 22. So we say that we have a median of 22 push-ups. And I know someone mentioned this already, but just for the sake of being thorough, so as some folks mentioned, if there are even number of items, such as this list here that has 6 items in it, we call that in order to find the median, we still conceptually look at the middle two numbers and then find the average of those two numbers. So here, if I happen to include a person that did 26 push-ups yesterday, then the median is slightly adjusted to be 22.5 push-ups by these calculations. Out of compulsion, you'll probably hear me say this about every 10 minutes, but if you do have any questions, feel free to ask them via the Twitch chat or wherever might work out. So, what I thought I'd do is actually try to bring in some visuals to make the next point. And admittedly, those who've taken the statistics class before realize what I'm getting at, anyways. But please bear with me. I assure you that the class will be a little bit more difficult in future weeks. So, for the computer code, I do not expect you to understand everything that's going on at the moment. I'm just bringing us to the graphs for now. In fact, towards the end of the semester, you might not understand every single line of code, and that's fine. No one does. I simply put the number of push ups on the y axis here for computer programming reasons. And again, the setting is still the same. Suppose that we just surveyed a bunch of people and asked them how many push-ups they did yesterday. For what I'm going to drive at, amongst these data points that I have in black dots, I calculated, or I had the RStudio calculate the mean, put that as a blue dot, and the median, and put that as a red diamond. Moreover, in my simulations, I simply said, suppose that we surveyed 20 people and recorded how many push-ups they did yesterday. We got this table here, similar to an Excel spreadsheet. Don't worry about trial. It was just something I hacked to make the code work. So I have this information saved in what's called a data frame. And I simply gave it the name push-up data. And it has a column of numbers for the number of push-ups. To calculate the average now, we take the mean from the push-up data, and this dollar sign for now simply means which column are we referring to. The mean of the push-up data specifically focused on the push-ups. It's a little roundabout, but you might see in a couple minutes why I did this. And at least for this sample of 20 people, the mean was about 22.9 push-ups. And I just want you to think to yourself for 10, 20 seconds. How do you think we're going to compute the median? And your best guess turns out to be correct. Instead of typing mean, we type median. And we get a median of 24.5 push-ups. So this is now 20 people. We have this data here, or this graph here. And what I want to do with these graphs is to kind of point you towards the concept of how the dots can be spread out. But at the moment, simply talking about mean and median, you could see that the the red diamond for mean is somewhere in the middle of the dots, and the blue circle for median is somewhere in the middle of the dots. Um, Imagine that's what you would expect. So, for whatever you think about this crowd of people doing approximately 22 push ups a day, what if all of a sudden you had a survey respondent that came in and said, well, I did 100 push ups? Just kind of think, how would that affect your calculations, if anything? How would that affect your results, if anything? So, what I did in my code, which by the way was the R code, I'll upload a copy to Cat Courses later so that you don't have to copy this. You do not have to copy this now. Long story short, I attached that theoretical hypothetical person that did 100 push-ups to the data. So now I called this situation the push-up data with the outlier, so that Andrea Adonis with their 100 push-ups is now tacked on to the data set. So now, doing these calculations again, if I wanted to find a mean number of push-ups with the outlier, well, I just got to make sure, because of the way I had set up the tables, the data, to make sure I'm including the outlier this time. And now the mean has jumped up to about 26.6 push-ups. While with the outlier, if we wanted to compute the median, fortunately, if you're doing this by computer programming, computed median is literally just typing out a tiny bit more. And we get a median of 25 push-ups. So the differences, literally subtracting what happened to the mean before and after dealing with the outlier. The mean increased by about 3.7 push-ups. Whereas the median increased by just half a push-up. Let me bring this back to the Google Doc at times when it makes sense to do so. I did press Control V. Fine, you want to do it that way? Do it that way. Waha. So, like you guessed, or the folks in chat mentioned, that outlier skewed the data, skewed the calculations. But observe, because of the way we do the calculations, how we find the sample mean versus how we find the median, the mean gets skewed or pulled aside more when we have that outlier versus just the median. To put this in nerdier terms, statisticians say that the median is robust against outliers. It's more outlier proof than the other calculation. Now, at least for me, these numbers that I spit out earlier, here in the middle of the page, are not that impressive. But I think I built up some decent visuals, so let me bring those in. Here we have that first graph again. We surveyed 20 people yesterday. How many push-ups they did yesterday? Computed the mean and median. And here's what happens when we include the outlier. So let me see if I could bring this into the Google Doc. And let me ask about 10 people to describe what the outlier did, at least in the graphs, in the visuals. So go for it. Right. So as our volunteers, or the group here has told us, you could see that the outlier was represented in the picture on the right, but it due to the placement and the scales, it kind of made everything else obscured. Everything else got squashed together. Made it harder to examine the mean and median. And yes, very much skewed the view of the graph of the data. Thank you. So now we'll move on to a situation like this. Let me read off the example. And this is coming from that community college class I mentioned a while back. Going into the final exam for Math 10, calculus had earned the following marks in the other categories: a 95% in attendance, a 75% in quizzes, 60% on the midterms, and 90% on the project. We're going to quickly look at the calculations that come up with the common questions that usually occur around this point in the semester. What is his current grade in the course? And what does he need on the final to earn at least 80% for the semester? So let me ask the about 10 people. If a hypothetical student came along and did that calculation, what is wrong with that calculation? And as are mentioning, the calculation did not account for the weights, did not account for the weighing of the components. And we furthermore have recommendations of how to do the calculation. There will be times I'll probably switch to a different program to type the mathematics, but since this is just one or two calculations, I might just try to just shove it into the Google Doc here. So as you recommended, we have to multiply by the weights. And it turns out that you would need to divide by the sum of the weights. Okay. And my hypothetical student had about a 76.67% in the class at the moment. Let me see if I could put the table on the screen just to double check that you could see where the numbers are coming from. So, just thinking to yourself for a few seconds, you realize that in my table above, I did not mention how much the final exam was worth. So, just in your own head, make an educated guess there. And you were correct in saying that is the remaining 25%. So, just because it's a little awkward to type out equations, and I'm not going to emphasize this too much, let me just quickly address part B here. What does he need on the final to earn at least 80% for the semester? Well, we take his current grade times the 75% of the semester he did so far. We don't know how much he's going to earn on the final yet, but that final, as you figured out, was worth 25% of the grade. And we want that to be at least 80%. when you solve out this inequality, it turns out that the hypothetical student, calculus, needed at least 90% on the final to improve his grade in that scenario. Earlier in the Twitch chat session, someone maybe sarcastically asked, out of all things you as a math teacher could talk about, why push-ups? And I've seen a few colleagues take part in this social media campaign of 22 push-ups to bring awareness to the military members who have last committed suicide with their stress. So this whole time I could have been talking about military suicides instead of push-ups. There's a question in chat about office hours. The discussion section leader has his office hours on Tuesday morning. I have my office hours here in the same setting on Twitch, etc. On Twitch on Wednesdays at 4 p.m. But moreover, you could also ask questions asynchronously via Discord, and we'll try to address questions as they come in there. I still have to answer a few emails as well. Alright, so at the end of each lecture session, I ask that everyone, and this is required, give me a little feedback in the form of the reflection. And once you're done with the reflection, that will be it for today, and you'll be free to go.
drive through Bordeaux when it hurt all alone, but it'll be just fine if heaven's secure. I was lost, I would cry, I would wish all night that it'll be just fine if you aren't leaving for good. I could hear you on the radio playing when I was riding so stuck in Vegas. You said we could never be strong, but our hearts are golden and connected as one. Through lonely days, we got better as they came. We are electrolytes flowing in the rain. We are electrolytes, taking your breath away. I could run for my life, I could see your